what is the diode and how does the diode work. Diode is made from a small piece of semiconductor material, usually is silicon, which stop as P region and N region. P regions is made by a semiconductor by adding trivalent impurities, and N region is made by a semiconductor by adding pentavalent impurity. The N region and the P region in our diode. In the N region, the majority carrier are electrons. And on the other hand, in the P region, the majority carriers are holes. The PN junction and the depletion regions are between the P region and the N region. The P region is called anode and connect to the conductive terminal. And the N regions are called cathode and connect to the second conductive terminal. So, how does the depletion region form? At the instant of the junction formation, the free electron in the N region near the PN junction will begin to diffuse the junction and flow into the holes in the P region. So, for every electron that diffuses across the junction and combine with a holes, a positive charge will left in the N region, and a negative charge will create in the P region, forming a barrier potential. This action continues until the voltage of the barrier repels the furthest diffusion or equilibrium.
The positive terminals of the bias voltage is connected to the P region of the diode, and the negative terminals of the bias voltage is connected to the N region of the diode. It will cause the depletion region of the diode become narrow. During the forward bias, we actually get the situations where far few of the free charge carrier are able to diffuse across the depletion regions, so that the depletion region become narrow and smaller compared with the river depletion region. This situation will conduct the electrics and let the electrons flow through it. Reverse bias occurs when the negative terminal of the voltage source is connected to the P region of the diode, and the positive terminal of the voltage source is connected to the N region of the diode. This will cause the depletion region of the diode become widened. Because of this, the current cannot flow through the diodes. Because unlike charge attracts, the positive side of the bias voltage source push the free electron, which is majority carrier in the N region, away from the PN junctions as the electrons flow toward the positive sides of the diodes. Addition positive charge ions are created, and this is the result why the depletion region become the huge depletion region.
This is the IV curve of a forward bias and reverse bias of a diode. As you can see, the VF is increases to the right and the IF also increases upwards. But did you notice that there is a significant increases at the point of 0.7 volt, and at this point we also cause the nick of the graph. The IF increases rapidly as shown in the graph. This is because below the nick of the curve, the resistance is greatest because the current increases very little for a given change in voltage. The resistance begins to decrease in the region of the nick of the curve and becomes smaller above the nick where there is a large change in current for a given change in voltage. So when we move to the left of the graph, this is the reverse bias, and the VR increases to the left, the IF also increases downward. When VR reaches VBR, the IR begins increase rapidly. In real condition, diode will function in normal operation of PN junction device. The value can vary typical for silicon. The reverse bias will causes overheating and possible damage to diode when the VBR is greater than the VR. Thank you.